Okay, so an interceptor contains a filter. We've established that, and in order to stop pollution entering the environment, you need a range of barriers that address the different contaminants entering the interceptor. So in the scenario we're talking about, we are likely to have runoff from vehicles. So that's primarily diesel and petrol. And the two simple elements of that, the diesel and the petrol, float on water, and an interceptor is designed where its inlet is at the top, its outlet is at the bottom. So really, the body of water is helping to prevent any diesel or petrol departing. The filter mechanism within there is designed to prevent any soluble hydrocarbons, anything that's mixed into the water or isn't floating. That will be, or indeed a heavy build-up of fuel within the interceptor, so it's dropping in its level. The filter prevents that getting out. And that may be a carbon-based product. There's a range of materials that will help to do that. What the ethanol filter is designed to prevent is those additional contaminants, which being the benzene, the toluene, and the ethyl benzene and xylene being able to get into the environment. So they come into the interceptor as part of the fuel body. Water at 0.14%, I suspect in your average interceptor it's about 98%, will readily say to the ethanol, come join me, which it will immediately. And the ethanol and the water combined are then telling the BTEX components that to come with them. And the BTEX will always have a propensity to mix with them rather than stay with the petrol. So in it, if you can imagine, you've got a beaker of water, which has got a film or more of petrol and diesel at the top. And within the water, invisibly, are these contaminants. Now, water is designed, the interceptor is designed to allow water to flow through. So at the moment, under normal systems, through go those contaminants and out they go. The purpose of the filter is to prevent that happening. And they're very small molecules. It's very difficult to have a physical filter that will allow water through, but will stop other molecules getting through. So the material isn't based on the size of the aperture or the hole. It's based on its attraction to those contaminants. So the contaminants bond to it. And to get to that point, the Adrenaline team had to invest a great deal in R&D to try and understand the science behind that. And we had to approach a range of different companies that not only provide filters and filter technology, but actually all sorts of things you wouldn't expect, like mattress manufacturers, people who really have an in-depth understanding of how molecules behave in certain environments, and bonding something to something rather than physically preventing it moving was an interesting development in the case. And by establishing that we could get the nasty contaminants to bond to something allowed us to create this filter, which is unique.